Clustering is an approach that is very close to load balancing but differs slightly in the way it's implemented, as well as the reason it's put into place. A load balancer distributes client requests across available server nodes in a farm or pool in which the nodes are completely independent from each other. This is done to manage traffic peaks in real time. Clustering, though, is an approach that fronts processing nodes sharing data with one another, and the goal is to provide redundancy and high availability for systems such as databases, file servers, and others. In a single word, the difference between clustering and load balancing is that clustering provides failover. As an example, an organization may want to provision two databases, called nodes, so that if one fails, the other can still handle client connections. While load balancers are usually configured with a dedicated IP address, two nodes in a cluster would share a single public IP address, such that to anyone on the outside they would appear as a single node. This is referred to as virtual IP, also commonly referred to as a shared address or a floating address. Each node is configured with a private connection, but to the outside world they have a single real IP address. Common Address Redundancy Protocol, or CARP, is a redundancy protocol that allows an active node to own the virtual IP and respond to connections. This protocol implements a heartbeat mechanism to allow failover to the passive node if the active one should suffer a fault. Note that we just called one of the nodes passive in our previous example. This scenario is referred to as active-passive clustering. The advantage of active-passive configurations is that performance is not affected during a failover. The downside of this configuration is that they come with a higher hardware and operating system cost because of the unused capacity just sitting idle until needed. There are N+1 and N+M configurations of an active-passive configuration that provision fewer passive nodes than active nodes, which reduces costs somewhat. An example of an N+1 configuration might be 3 active nodes, with another passive node just waiting to be used if either of the active nodes fell, 4 nodes in total. We can also use an active-active cluster in which both nodes are processing connections concurrently. This allows us to use the maximum capacity from all available hardware when all nodes are functional. If one of the nodes fails, the workload of the failed node is immediately and transparently shifted onto the remaining node. However, the workload on the remaining node will become higher and performance may degrade. We can also apply clustering to application services. If an application server suffers a fault in the middle of a session, the session state data will more than likely be lost. Application clustering allows servers in a cluster to communicate session information to one another. As an example, assume that our web servers maintain session state in memory. If a user logs into one instance in a cluster and that instance fails, another instance will be able to access the cookies or other information established during login. From the user's point of view, nothing bad happened and everything is normal, while the cluster is aware that a node just failed.